Hello again, it's Cliff here from Down Under. Well, in this video I'm going to talk about work location, work stops, particularly for the milling machine, how you might stop or locate your work. A very useful piece of equipment if you're making multiple parts. And so I'll go into the different applications for these stops and some tips and tricks along the way. Quite a short video, but at the end of the video I'll go into how you might make your own stock if you like one of these designs briefly. Alright, cheers. Quite often the best surface on your work to have a stop is actually a problem for part removal or machining. So you need to have a stop that is retractable. Have a look at this stop. So it can be adjusted to any position, and it has a collar on a sliding shaft. I'll just put the camera on a tripod and show you exactly what I mean. So this allows you to have a stop on a surface that would otherwise be problematic. Okay, so let's say you want to machine on the end of this part, or you need to be able to remove the part out of your collet or chuck that way. Then a fixed stop is a problem, and a sliding stop is very useful. So you can just slide it in there to the collar and then slide the work out and then lock up your collar. And sometimes you may want to actually have it fixed as well as sliding. So you can have it sliding up to the collar, then you tighten that up. So now you have a fixed stop. Now you can tighten up your collar, your collet, without having to worry about your shaft sliding back as you do so. So both hands are free to keep the work pulled up against the collet, because the collet tends to draw the work away from the stop. So you need both hands, one to pull the work and one to tighten the collet. Then when that's done, you can loosen the clamp and slide that back or completely out, and now you have all the clearance for your machining or your part removal. So that's very handy to have a retractable stop, something like that. I developed this type of adjustable stop so that it was universal and I could use it in my different milling machines that have different size T-slots. This cylindrical base sits in the T-slot a bit like in a V-block, and so it can fit into different size T-slots, and it has a T-nut inside it that can be turned around to suit two different widths of T-slot. So it's a sort of universal stop that can fit into different size T-slots in the base, and it's got adjustable articulated arms that have the same size cap screw. All three cap screws are the same. That means one key, and you can quickly adjust it to size. A note here on chuck or collet choice. I've just replaced the collet chuck with a 3-jaw chuck, because when I tightened up the collet I need to rotationally align this part, and the collet was turning the part as it tightened and also pulling the part back off the stop, and it does it a varying amount, which makes it very difficult for precision setting. So often you're better off with a 3-jaw chuck you can float into concentricity with those adjusting screws you can see there. Get it concentric. Then when the jaws are tightened, they don't rotate the work or pull the work lengthwise, and that's a big advantage. And if you've got a little chuck like this little 4-inch, you've still got plenty of clearance around the cutter and cutter holder. It's usually almost as good as a collet. In some situations it's got better clearance because the jaws project forward with their stepped shape. You might be thinking, well, what do you mean float your chuck on a faceplate or backplate? My chuck doesn't have any holes there, so I can't screw it on like that. That's what I'm referring to, those holes running in that direction. If you don't have those holes, and most chucks don't have those holes, you can usually drill these holes right through. So check the construction of your chuck, but I don't think I've ever struck a chuck where this mod can't be made. So you drill right through to the front and then counterbore it, and you can use that size screw to mount your chucks from the front, and it makes adjusting, dialing it in with a dial indicator concentric very easy. Before I developed that T-slot style adjustable stop, I had this design, and this is the prototype of it here. I was thinking of manufacturing this at some point. Anyway, I haven't got round to that, but this is the design. There's just two cap screws. One allows you to slide the mounting plate and adjust it on an angle, and the other one allows you to slide the stop rod, the set rod. And this is very compact, rigid and versatile, but it does require that you drill and tap a mounting hole in the side of your vise, or you probably want one in each side of your vise. So for some situations this is more useful, and in other situations the T-slot style universal stop is a better option. So I just pistol drilled and tapped a little thread on the side of each of my vices. These are M5, but I think M6 would be a little bit harder wearing. A very simple, practical way to mount your stop that's nice and tidy and streamlined. Different stops are already available for purchase, but you may like some of the features of these designs that I've developed, and you may want to make one like this vice stop or like this table or T-slot stop. So I'll just quickly go through some of the key dimensions. Obviously the dimensions are not critical because it's an adjustable stop, but just to help you head start on that, it could be a good little workshop project for somebody that's feeling like making something for their workshop. So let's go through the vice stop quickly. It's a 4mm rod, or imperial equivalent to these dimensions obviously, about 9mm thick by 21mm of bar. That's the main block, about 75mm long with a slot in it. This is a 5mm screw. I think a 6mm would be slightly better, slightly harder wearing. You can have different length standoff pillars to mount your stop further off the vise with longer cap screws and clamping washers. This is all back to front, this camera above me, like that. So that's the vice stop, rough dimensions there. The table stop mounting in the T-slots, I've got different capacity for different T-slots by turning the T-nut round in different directions. I can take one size T-slot that way, turn it round, and another size T-slot that way, and it mounts in a sort of V shape in between the T-slots. So that's a 20mm piece of shafting there, about 50mm long, and the bars are, you know, they want to be fairly substantial, otherwise it's going to be too flexible. It's 15 by 11, something like that, that you have conveniently a bit of gauge plate or a bit of key steel. Again, 4mm rod. I used 6mm cap screws for all the three clamping threads there. Oh, and I nearly forgot the length of the arms. So the bottom arm is about 68mm between centers, and the top arm is about 60mm between centers, a little bit longer overall. That's about 80mm. So give you an idea of the length of the arms. That suits a 6-inch Kurt Weiss type arrangement, which I imagine will be quite common, the height of the vise from the table T-slots. just have a bit of a look at that. So that's probably enough information for you to knock something up out of scrap material that you already have. And then there's lathe stops. That's another whole subject. A hugely useful device that allows you to do production work so much more quickly, and you can reference off the back end of the part. I found this was a huge time saver when I got into it. Perhaps I'll do a separate video on this subject, because I think I'm beginning to realize people want to watch short, sharp, concise videos relating to the title subject. So I'll do another video on lathe stops at some stage. Thanks for watching, guys. Cheers.